All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's October 28th, 2020. My name's Eric Osterman, and I will be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator. That means that we help companies own their infrastructure in record time by building it together with your team and then showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. We'll automatically post a video recording of this session to the Office Hours Slack channel, as well as follow up with an email so you can share it with your team. So with that said, let's kick it off. And got a couple news items here to bring up. One is the exciting announcement is that the ALB Ingress v2 has finally been released. And why that is really nice is that the ALB v2 lets you reuse the load balancer. So previously, in your Kubernetes cluster, if you were deploying multiple apps and each app defined its own ingress, each one of those became a load balancer. That's kind of not the point of defining ingresses. This now allows you to specify which ALB you want to share, and then each ingress will be updating that. So it works a lot more like Nginx ingress if you've been using that. Has anybody already kicked the tires on this? All right. So the other announcement is HashiCorp has released an experimental support for AWS Lambda extensions. So I don't do that much with this with Lambdas, but it does seem like a welcomed addition. And the idea with Lambda extensions is basically it's similar to hooks almost. Or init containers in Kubernetes in the sense that it is a process that runs before your Lambda is invoked and can set up the environment for it when it starts. That process can run can be in a totally different language and can be generalized. So what they've done with the let's see here. With this is they have a process that will write out your secrets to a file before it invokes your Lambda, and that way your Lambda can be generalized and can be not Vault aware. So I guess that'll lead to greater interoperability with other Lambda type of providers or serverless providers. Maybe it'll facilitate local development as well without needing to depend on access to a Vault server. Anybody know some more about this or excited about that? All right.
Seems like a single point of failure.
What? Oh, sorry. I heard something there, but very faint. Is that just me or?
I don't know where my mic is. I was just trying to say it sounds like a single point of failure injection.
Well, okay, that's a fair jab, I would say. Maybe a cheap shot. I mean, yeah, if you're depending on Vault, HashiCorp Vault in general, regardless of AWS extensions or Lambda extensions, yeah, it's a single point of failure. That's pretty critical, right? It's in the critical path of everything. So if Vault goes down, then yeah, everything is hosed. But I guess architecturally speaking, Vault is on the easier side of things to manage in HA. That said, if you can get away with SSM and ASM, that's probably that would be our recommendation. So you have less moving parts. Yeah. All right. Any other additions? All right. So the other thing that I was just in my news feed that I was reading, it was quite nice. What I liked about it is it very succinctly laid out the various types of attack vectors on Kubernetes in a general way, and it shows the areas that you want to guard against or protect against, either through policy controls or other hardening on Kubernetes. Microsoft has their threat matrix, which was which is looks like this. But the key thing in this article is it's pointing out the things that were noticeably absent from that threat matrix, and those are the ones in bold, are the ones that the article points out should also be considered as those. You know, the container lifecycle hooks are definitely one area to be concerned about, and you know, sidecar containers and the pods. I mean, the Docker images that you're pulling themselves, whether or not you can exec into the container, you know, host level file system access if that hasn't been disabled through policy controls, etc. So I just thought that was some good reading. Don't have an answer for all those things. I will share that in the Slack here. Any other interesting announcements this past week that caught your eye?
Fargate spots. I actually realized it was just announced in one of the region, but I didn't knew about it. So that was.
I didn't hear the first part of that. What was that?
Fargate spots, running Fargate task on the spot containers on AWS.
Oh, Fargate support for Spot.
Yeah.
Gotcha. That's cool. How does that? Yeah, I haven't looked into it at all. How does that work?
Fargate for ECS or Fargate for EKS?
Spot.
ECS, I guess.
Spot for ECS, yeah.
ECS had Spot for a while. It's not new.
But for Fargate, ECS Fargate.
Yep.
Okay.
Yeah, that's for ECS Fargate. Yeah, we were able to run the spot fleet on ECS instances, but this was for Fargate.
Yeah.
Yeah, but I think that has been around for a little bit. It's just not widely used or known about, actually.
Yeah,
I've been using it in production for a while. That's why I was so surprised, because I thought Fargate for EKS finally got Spot support, but that's not a thing yet.
That would be cool. EKS Fargate. I'm curious, who's using EKS Fargate for their workloads? We haven't been using we have a module for the Fargate profiles just to support it, but we're not actively deploying to it.
I'm using it.
How's it been working for you, Matt?
It's been good. I have no problems. It is, I question it for sure, only because it's a pain that I have to create one-off sidecar container configurations for Helm charts. Like it feels like I'm building like a little snowflake for each sidecar that has to run alongside the pod. But other than that, it's reliable so far.
What's the sidecar you're talking about?
Running Datadog as a sidecar, and also soon to be FluentBit. I was just implementing that this week.
That makes sense. Yeah, true. I forgot about that.
Yeah.
Yeah. So yeah, exactly. You can't deploy Datadog as a daemon set on Fargate profile. So then you have to just deploy it as a sidecar everywhere.
And it's easy when it's a daemon set, but like when it's not, it's a real pain.
Yeah. That's a little gotcha right there for sure. Anybody else?
Well, not using Fargate, but one of the announcement was that AWS announced the OpenTelemetry support. They came up with a distro for that. So that kind of becomes the news because we are using some of their partners already, as in for the observability solution. So there is some chatter around that going on for the last few days.
Yeah, I can see the excitement around that if you're already using something around it. Nothing I've looked into, so I don't have an opinion.
they sometimes, that's like, I think a few weeks back they announced like Prometheus metrics integration with the CloudWatch dashboards and such.
Hmm.
So we were looking into that. It's not clear yet whether they are going to be providing storage as well, because one of the things with the regular Prometheus would be the storage.
Exactly. That would be really
So
exciting news, actually, if they provided a Prometheus compatible storage backend
yeah, so it's
that
not
didn't charge
clear.
25 cents per metric.
Yeah, 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 true. So yeah, we are looking into that. We don't know if we're going to go that route, but at least it's something to look for.
Yeah. Cool. Thanks for bringing that up. All right. Well, let's dive into some of the talking points. These are questions that were asked either in the Office Hours channel or that I kind of dug up by looking through the various channels in the sweetops Slack community. If you haven't yet joined our Slack, go to slack.cloudposse.com. Again, that's slack.cloudposse.com, and you can sign up and follow along in the conversation there. All right, so one of the questions this morning was, what are you all using for local Kubernetes development? So we're talking like, back in the day, Minikube, and now some other options like Scaffold. Matt, I saw your post there as well. I forget what I've seen that as well. I haven't checked it out yet. I'm gonna open the link.
Yeah,
here.
Tilt.
Yeah, tilt.dev. I remember that. It's come up previously in Office Hours. So I'm curious about this, honestly. For anybody else practicing using Kubernetes locally, I will say that to me it hasn't lived up to reality yet, and we don't do it anywhere because most of the effort for us in deploying a new service to Kubernetes is getting like the service account roles right, or getting it to integrate with RDS or all these other things, and all that stuff doesn't help me having the local development environment. And since we use our Cloud Posse mono chart, it's pretty much just typing out a bunch of images that we pull remotely, so we don't even have to do much chart development. All right. Let's see, why is this not loading? Open in browser. Anybody successfully using Kubernetes for local development and improving your development workflows?
I've been using microcates a lot.
Microcrate?
Microcates, it's by Canonical.
Microcates. I gotcha, yeah.
Definitely bugs and lots of corners and edges, but it works pretty well for what we're using it for.
And how are you guys using it for local development? What's the rest of your tool chain consist of? Are you using Helm file, or using Customize, or what? How are you deploying on Kubernetes?
We use Helm file. We're in Azure, so we're using EKS. We use ACR, but especially for getting other devs like into Kubernetes and showing them the ropes, it's handy. I'm doing a lot of experimenting. It helps.
Yeah.
So just question, I was the one who actually posted this. So what are you doing in order to do the CICD of it, right? So you are maintaining two configurations, one for local and one for cluster, wherever you are deploying it.
Yeah, exactly. And this is a recurring theme. It's like, what are you optimizing for? So for developers, you're optimizing for the local development experience for like possibly service-oriented architectures, or aka microservices. Then you have like your production environments, which are optimizing for performance and not debuggability and traceability. And security and consistency and hardening. And then you have maybe your preview environments where you're optimizing for running it in Kubernetes, but not necessarily with your production configuration, because that would be time consuming to deploy, expensive to operate, and complicated. So we optimize for basically three kinds of scenarios. For local development, look, Docker Compose has been very effective for teams. They understand how it works. Anything that's written in Docker Compose will more or less work in Kubernetes. unless you're depending on just tons and tons of operators, for example, to power your stuff. But if you're depending on a lot of those operators, your mileage may vary anyways when you're trying to run that inside of your like little local cluster. Like, if you're depending on, say, Cert Manager or external DNS or Istio, all that stuff is going to be complicated to set up locally. So we try and keep it as simple as possible. If your apps run containerized under Docker Compose, it's very easily to translate that into a Helm file release that we deploy.
So you use multi-repo or monorepo?
Great question. So this is, first of all, not something we get to dictate. We are a quote unquote DevOps accelerator, which is a fancy way of saying we are systems integrators, which means that we come into a customer's environment and they kind of like, we can't say, look, you're using a monorepo, we only do polyrepo, refactor, or go away. So if the customer is using monorepos, we support using a monorepo. If the customer is using polyrepo, we support doing that. The challenges come into, not all monorepo projects are the same. We're working with a customer right now through some of their challenges, working with a monorepo, and it's easiest if you're running a monorepo with decoupled services. If you're running a monorepo with tightly coupled services, yeah, I don't have general advice.
Okay, so what did you find easier to maintain and deploy, like monorepo or polyrepo? Say, for example, I'm starting a new project, right? And I want to decide, should I go with poly or mono? What should be my go-to choice?
Yeah, this is a great changing topic, digressing to a new question. Like,
yeah, because everything ties up.
Or should we do monorepo? That's a good question, and let the holy wars begin.
Because everything is tied up to that. The way you are structuring your repository, the way you are structuring your Docker Compose files, or maybe your local Kubernetes configs, and your CICD pipelines, deployments, and stuff.
Yeah,
everything changes with this single point.
Yeah,
it's more about how your company works and how your teams and your engineers work rather than how tools work. You can twist the tools to work with whatever hybrid strategy or big stream strategy you want to, but it's more about what your app is, how many of them you have, how many people you have, how they work together, how they release, how they work with marketing for releases, and so on and so forth. It's not a technical problem, it's a people problem mostly.
It's people problem. Both of them have trade-offs. There are successful multi-billion-dollar companies operating on both models. I think you're going to get very different answers depending on who you ask and what people have been practicing most often. We worked with a customer 1.5 years ago or so. They were all ex-Googlers and were very keen on a monorepo approach. I'd like to say that we didn't succeed with that project, and maybe it's and we learned a lot working on it, but we didn't entirely succeed with it. We started with Terraform, and we did all the Terraform with multiple repos and polyrepos, and their apps were deployed with monorepo, complex monorepo architecture, all in Go and Bazel. But in the end, they went CloudFormation and threw all the Terraform away. I think if your mind works in a monorepo way, meaning that's what you've been exposed to, indoctrinated in, seen it work in practice, I think it's really hard to see it a different way.
Yeah. So I come from polyrepo world mostly. Most of the projects are polyrepo, and this is something which actually made me think about monorepo. Like, if you see garden.io, all those configs, I was exploring all the options that I was having online.
Yeah.
And Cardin.io is the closest that I was able to go that, yeah, this might be the tool which I'll be using for local Kubernetes development. But then again, if we think of multi-repo, it's kind of pain to set that. So.
What the biggest pain I see, and I've been indoctrinated in kind of like the model that HashiCorp has created with very much a polyrepo forward approach, with modules being in each repo, versioned separately, released separately, pull request history separate. Works pretty well. And the challenge is when you go with this monorepo approach, like look at the companies doing it. For example, like a Google doing it. A lot of what they do is all original, all in-house, and yeah, I get it. But when you're trying to integrate then with a lot of third-party open source, your real option is only doing vendoring. And vendoring is something that is well understood in certain languages or frameworks, but as a generic pattern across tool sets, vendoring isn't universally just documented how to do it. We're working on something at Cloud Posse right now. It's actually going to be part of our reference architecture and how to do some vendoring. But it's a challenge.
Yeah. Okay. So I'm normal, right? I'm not seeing anything abnormal. The problem which world is facing, I'm facing the same. I need to dive through that, I guess.
Yeah, and it's offloading a lot of, it offloads a lot of that complexity onto the tool chain. And like if you're using Bazel, for example, they have a lot of things to optimize the monorepo build architecture, but then they've created their own build system around that. And then when you want to integrate that into maybe if you're using a traditional build tool system like CodeFresh, Circle, or GitHub Actions, it's not doing that much in the end if you're going to use the build server architecture for Bazel, perhaps. Now, I'm not an expert at that stuff at all, so I'm far out on a limb talking about that. Talking about how to build, deploy, release polyrepo architectures is definitely in our wheelhouse and what we specialize on most of the time.
Got it. All right. Yeah, thanks.
One thing on that, Eric, you guys have decided that your root modules for Terraform, though, are monorepo, correct?
Yeah. So one thing that I really like on HashiCorp side, what they've kind of gone. So I think I'm leaning more towards conceptually a model where you have poly monorepos, if that makes sense. So you logically collect things or services together in a repo, but it's actually a collection of smaller projects in there. It works well in certain cases where you also have extreme proliferation. So we have our Cloud Posse packages repo. I would have hated to create a repo for each package we want to redistribute. So in this case, here are all these packages that we redistribute in Alpine or Debian or soon to be RPM format. And we took a monorepo build approach for this. So if you look in our workflows, we generate a workflow for each one of those monorepos. Now, I'm not. There are these things that the tools you choose to use for this are also opinionated, and some and how well they will work with a monorepo versus a poly or individual small repos. Your mileage may vary. I took this approach because I wanted to offload the challenge of knowing what files changed to GitHub. I didn't want to have to calculate that myself. But then that meant that I had to have lots of workflows for each individual service. This is an easy example though. What if Gauntlet was depending on another service in the same repo and that changes and this has to change? I guess it's still achievable in some way, but I'm not solving it here because it's a much easier case. Where we're taking then you brought up this example, Matt, which is our Terraform root modules. And This was our first foray into kind of doing some level of monorepo with Terraform. And these are largely out of date, and this is not what we're using for more than a year at this point. That's why you see a lot of stuff is out of date. The stuff that's been updated is like maintenance work for existing customers. The approach we're going is with our reference architecture that is perpetually in progress now. The reference architecture here, we'll talk more about it once there's more here, but literally this morning I tasked more work related to this. Where we are headed with this is with a hybrid approach of vendoring for root modules and projects. So projects is each Terraform project goes in here. So you have like a VPC project, an IAM project, a DNS project, a EKS project, a RDS project, etc., etc., etc. So those are your root modules. But how you invoke them, the configuration of those, is yet a separate layer of abstraction. And this is a lot too much hand wavy, and I don't want to get into this until I can actually point you guys to some exact examples, and we'll have something for that in a month or two. I've been saying that a lot, but I think it's real this time. We'll see. So Terraform monorepos, yes, or poly monorepos.
So one thing I noticed, the challenge that I faced is, when it's easy when you're using modules at the root of your Terraform code, but it becomes really a challenge when you're using modules inside modules. It's hard to maintain.
You can't do vendoring from a security perspective, but you can still do vendoring of the top level module that you're including.
Yeah.
No, this is a gnarly problem. I thought, oh, this is going to be easy, and it wasn't. So, we develop a lot of modules, of course, and we develop a lot of composable modules, smaller modules, narrow in scope. One does one thing well, and then we compose them. So that composed module, sometimes that's a root module, sometimes it's just another module. So an example of that would be like our web app module is a pretty opinionated way of deploying an ECS task. And if you look at this one, it's really a showcase for how to tie all the other modules we provide together into one module that does a heck of a lot and inherits all the functionality of all the other modules without having to stick all of that into one massive module with a massive surface area. The problem is, if you wanted to vendor this module, you're not going to be able to vendor all these sub-modules very easily because they're versioned. And the other thing is, you might be referencing other modules or the same module multiple times at different versions. So when you do vendoring, it has to take that into account as well. And we cut bait on that. And the vendoring I'm talking about now that we're working on is just vendoring the first layer of the module.
Yeah. So I inherited it. At a project that I'm doing, and it becomes really challenge, because it's all into one place, and then modules are also there. Modules refer to it themselves, and then I'll need to do a forecast, right? That this is going to be version when I'll be releasing it. Yeah. And then I try to do a future with a PR, and then I'll need to do release as soon as possible, right? Because it's going to break the thing. So yeah, it becomes really hard to maintain when you are using this kind of setup.
Yeah, I agree. It's not a solved problem yet. I think what happens is individually organizations come up with a workflow process that works for them, but it doesn't always translate.
Yeah. So I always, whenever I see someone going into that direction, I just stop them right there, and then try to convince them. Okay, let's go with a single. We are not doing an inheritance, like no modules inside modules. Put that together, and I read it somewhere on the Terraform talks as well. So they are also recommending it.
Very cool. So Matt, you had another question. Think it might be a little bit premature, but anyone using Waypoint build packs yet?
So I think that there's a misunderstanding because
Okay.
I found out about this project, Cloud Native Build Packs, through Waypoint because their pack command, which is one of their like pluggable ways to part of their build process. So you can use pack or Docker right now. But Cloud Native Build Packs are basically what Heroku does to your source code with just being able to git push code to Heroku and it builds it and runs it. Build packs are that way of
Waypoint's
that outside of Heroku.
Yeah, so Waypoint does that with their build packs. Is Waypoint using the cloud native packs?
Yes. Yeah. So Waypoint, Waypoint is using a tool called Pack, which basically, and I'll post a link to a talk about this that's really good. But the Pack tool basically uses build packs, which is like the backing technology that allows it to just introspect the source, run the source against what it could possibly be against a number of build packs, like, oh, if it figures out that it's Java or it figures out that it's Maven, and then, you know, create a CNI, or wait, is it OCI? Whichever one is the specification for container images that's like, you know, the big new thing. It will create that as the output of running Pack. And then you get an image. So you don't need a Docker file, but you can get a Docker image or a Docker image compatible image out of running Pack, and you never need to specify a pretty boilerplate Docker file. And the reason I was asking about it is because I'm interested, if anybody is using this, I would love to hear, you know, where does this break down? Like, where is the line where it's not complicated enough to deal with X, Y, or Z? Because I'm sure that's what happens. I just, I'd love to hear about it if anybody's using it.
I'm not using Waypoint specifically, but I actually happen to have some background. I used to work for Pivotal Software.
Pivotal's the other one behind Heroku.
Yeah, I was on the operations team running the Cloud Foundry reference architecture. So like build packs are interesting because they're and hopefully I'm responding to your question here correctly. But like where it breaks down is that like because you're using a dynamic system to essentially generate the image as opposed to manually specifying like how you're going to build your Docker file, which is I think the two approaches that there are. You could either have a machine do it, or you could figure it out yourself and then specify in a Docker file. The benefits to having a machine do it is that you get to incorporate you get to have a place to plug in operator centralized updates. So what that means is the real advantage isn't the fact that you have a machine do it, because frankly, any developer can figure out how to get their application running in an image. They select the operating system, right? The base image, they select the middleware they use, but then they have to update it later. And a lot of times they don't. So the advantage to using a build pack is if you use a dynamic system, when say the base image gets updated, like so you're using Linux 3 and then you want to move to Linux 4, then all your running apps through your platform can be rebuilt using Linux 4. And if they fail their health checks, then they just won't roll. And then you have something you can trigger on to follow up action. So essentially what you get is that the build packs offer you a way to have the platform automatically update their running images. That's really the key thing that the build pack offers you.
Yeah, like you can hot swap out a 0-day security issue without having to rebuild the project from source. It has the existing source, but if the base image from an API compatibility standpoint matches up to a new base image, then it can be swapped out.
Absolutely.
I thought that was super cool. Yeah.
So yeah, that's the primary, I would say the primary advantage to using a build packs based platform. But as you might have already noticed, it's fairly complex. It's not. This is probably something that's really ideal for like more enterprise type situations. And I would say, if you're anywhere under 1,000 people in your company, it'd probably be easier just to have people doing their own Docker files and having a policy saying like, hey, you got to go update your stuff. That's personal opinion. You know, your mileage may vary.
No, that sounds right. That's that was a great answer. I was just interested in it because it seemed like it was basically it seemed like cool technology. It's cool that somebody's working on this. Yeah. I really like the idea of like, yeah, if you're a security focused company and you can just swap out, you know, CVE issue pops up day one and you literally get it day one.
Yeah,
that's pretty
I remember sweet. In my pivotal days, we had like, I think it was a Heartbleed was the one, that one of the CVEs that we responded to. We had a new image shipped in like 24 hours because we had the early notice, right? But 24 hours. And then like we were running 50,000 containers in our environment for my customers. And we just updated everybody, like, you know, in a matter of like, I think 2 hours. That's just how long it takes to roll everything.
Very cool.
But yeah, that's the big benefit there, I would say, the ability to update and roll.
Sweet.
That is cool. The other thing it strikes me as is this is good. This is like low level tooling to build your pass, and which makes sense therefore why Waypoint is leveraging this as a more opinionated abstraction to this. I'm excited somebody's doing that like HashiCorp.
Yeah. Just as a hack week, like a month ago, me and some colleagues at my current company, we used a product called KPack, which is just an open source kind of variation on Pack. KPack provides some CRDs to Kubernetes to essentially offer you a build resource that you supply a what is it? A tarball of your application, and it turns it into a runnable image. So we use that to kind of build our own makeshift pass, as it were, just for a hack project.
This is the project, the one I hear on Pivotal, KPack?
Yeah, that's the one.
Cool.
Yeah, Pivotal got bought by VMware, so it's probably gonna go for a name brand change here in the near future. But yeah, essentially this is like a major component if you want to build such a system to where you have a platform that deploys, that builds your builds your images using buildpacks, and then gives you back an image file that you could then go ahead and create a deployment for.
That's cool.
Yep.
Thanks, Jim.
Yep.
And yeah, Matt, thanks for clearing that up. That was really cool. That was an epiphany there. I didn't realize. So let's see. The next question was actually from Eric Berg, who I see just joined. Perfect timing. His thing was, let's talk about some of our biggest failures in terms of what we learned. This is a really big open topic. Eric, the fact that you asked it, was there something you wanted to share? First of all, a recent failure.
Realize
empathize with you.
Try to confess something, Berg. No, actually, just because I've learned so much from some failures, and like. I think it's probably true for everybody here that the reason we're on a call like this with the rest of us is because we've broken stuff for years and years and years and have had to fix it.
Exactly. We've broken more than anyone else to get here.
Right. So I have one that I'll be happy to start off with. Do you want?
Yeah, I would love that.
So one of my first projects at Grubhub was to port one of the branding sites that's just like a list of menus, like 100,000 menus, you know, that kind of thing, from like some old data center to something that was actually managed. So, you know, worked with the developers, Dockerized it, brought it into AWS, set up some Jenkins stuff for build and deploy, got the monitoring around that. We're Datadog shop over there. And we, you know, but it was also one of those do as little as light touch, you know, just keep it light. So we were still using a Microsoft SQL RDS instance when we moved it over. And everything worked great for like a couple years. And then they were messing around with a stored procedure. And they were messing around with it in prod. And I was like, you guys cannot do that. I let them do it a little bit. And, you know, I was their SRE. So finally I was just like, okay, this must stop. And that was like a Thursday. Monday I came in and the site was like down. And the database was completely hosed. It's a Microsoft RDS problem. So like nested issue. Long story short, what happened was that whatever their stored procedure was doing wound up blocking. It was like holding on something. So we filled up the disks with logs to the point where it took AWS support like 9 hours to fix it. I'm trying to think of what crucial things I might be forgetting. Yeah, I mean, it was just one of those situations where, you know, there was just nothing to do. We had a cache sitting in front of, you know, we were using Memcache actually, but not for any of the searching, and most of it was searching. So they were just getting like 500s. Yeah. It was just ugly. But, you know, coming out of that, realizing like, you know, I stopped him in production. I was like, look, you guys, okay, I let you do a couple of runs of this, but yeah, it's just, I didn't follow up and make sure, because I was out, I think Thursday, and I didn't follow up to make sure that they had like cleaned up after themselves, like restored the stored procedure, what it was before and stuff like that. So like this thing was down for like, you know, mostly down for almost the entire day.
Yeah, that's I think those kinds of data. I think a lot of the failure stories will relate specifically to database oopses, drop all tables, kind of things. What I love to like. It's been a while since I personally have been operating in that capacity. I have fond memories though, of like, you know, you've done something and you just suddenly get that cold sweat, the oh shit moment that comes over. And it's this like, how do you communicate? Like, you know, you got to communicate it too, but it's like, the hardest days of our job is when bungled things like that. For me, vaguely, and it's not even that much fun to talk about, it was something related to that and Terraform state, and I totally corrupted it, and had to go back and recover all the versions from version control. But who has like a gnarly story? Anything?
Can we define biggest?
Go on.
Sorry,
Brad?
go. I wanted to define biggest. Like, are we talking in dollar terms? Are we talking in the number of failed spawns?
I think
in the number
I was
of people
thinking
involved.
Personal pain, like,
yeah,
you know, that feeling Eric just described.
Yeah.
You know, when it permeates your entire body and everything hurts for those, you know, and then you have to tell somebody that you did it.
Yeah.
Got it. Somebody started to share a story, so I'm gonna let them share.
Right. So I think this was for a project that I was doing for a Silicon Valley customer. They were a big security company, like, you know, doing those IP cameras and stuff. So they were running a lot of AWS instances, and it was a common practice where, you know, the instance, if instance is unhealthy, sees a lot of CPU utilization, people usually go to AWS console and try to deregisters from the load balancer, restarts it, and then puts it back. Now, the funny thing with the older AWS console was, you sometimes become confused. Okay, are you registering it or deregistering it? Someone actually, flapped it. So they only kept one unhealthy instance and deregistered all the healthy instances, which turned into the outage, and it was a big escalation because the production was down, created, and then the issue was with that other servers were depending on it. This was the main component, and then IoT is something where they start bogging the things up if something fails. So the log base started filling up, and then there were disk alerts, and things were haywire. It was a fault, user fault, but then we required to give an answer, and it was really tough situation for us. So people tried to hide it, but then they figured that okay, someone from the same team didn't knew about it, and then he checked the cloud trail and found okay, that was the same person from his team who did it, and then it was kind of a big problem. So that was kind of one big failure, maybe for a company who runs a lot many IoT stuff.
Yeah. The nightmare situation for me operating like some IoT site or device is this thing where how do you safely update all these devices, and what if something about that update breaks the devices, and that one bad update can oh.
So one thing is IoT is something that can, you will be the reason for your own DDoS stuff, right? If you put in a wrong update, your devices will start hitting you up, and then you won't be having any way out. So it's kind of a pain to manage that.
Same goes for a mobile app. If you have a mobile app just go haywire, it can end up DDoSing you too. I've had that happen before.
Yeah.
But now it's better, right? We can do a force update with Firebase. We can do that. You need to update it in order to use it, and we can block that right there. Things are becoming better in mobile world, but IoT is still the same.
Yeah. So that's actually a perfect segue into another question that was asked in the AWS channel. This was earlier in the week, and that was, how do you evaluate the right monitoring tool for your environment? I'm working on a Kubernetes microservices environment. There are so many SaaS companies out there, open source tools providing a similar set of features. Any suggestions on how to navigate this? And I empathize with this. Like there are like three major areas, I think, related to DevOps and where there are products making money. And it's CICD, it's monitoring, and it's security. And there are just too many SaaS offerings in each one of those areas. And I guess, your mileage may vary. Here are just some considerations, I think. One is, what is your team familiar with in terms of the resources you already have? I wouldn't over optimize on just looking at the requirements in the end, because you have to develop an opinion for how to operate it. So if your team has years of experience doing Datadog, but you see a new shiny offering come out from Sysdig or something, just switching, I don't think is going to solve all your problems. There are always going to be trade-offs with one tool or the other. Then the other realization I've just had this year more than ever, and it's almost a mea culpa, is that open source, there's this I think false belief as developers or engineers who are getting paid to implement it but not paying the bill to implement it in what things cost. As a business owner and Cloud Posse and running these things, Prometheus and Grafana, it's free, but it is not free to implement it and operate it and keep it up to date. We're doing another implementation of it right now, and everything has changed underneath our feet one more time. No reuse. And we have to rethink and reinvestigate and reevaluate what are the best charts to use, what are the best Docker images that are stable and maintained, and going through all that. And then Datadog comes across, and they've come a long, long ways, and it's expensive. But the other way of looking at it is you're amortizing that cost of maintenance for that other monitoring stack you're trying to do into a monthly payment with this provider that keeps it up to date, and you don't have to keep worrying about it. So the decision needs to come down. If you are a very large company and a very large team, consider Prometheus and Grafana. If you are a one-man shop, okay, and you just strictly don't have the budget, okay, I guess you don't have a choice. You got to go with something like Prometheus and Grafana. Just realize it's going to bite you sooner or later. And then if you have the budget and you don't have the team, just go for a managed service like Prometheus or like a Datadog or something like that.
So speaking of that, go ahead. Sorry.
Just real quick, I always like to balance the cost of an outage or a number of outages against the cost of the tools and support.
Yeah.
I want to, Charity Majors had a recent article, blog post, something, I've just linked it in Slack, about the future of ops jobs. One of those is vendor engineering. And it's very, very relevant because you cannot pick a monitoring choose based on requirements and what you think it is. Unless you, first of all, already use that tool, already have some experience with it, know how it works. And unless you actually used it in production in some way, seen it in an outage, you cannot really make an informed choice. You can pick the best thing that you think will solve your problems, but it's not gonna be that helpful.
No, it's really cool.
It depends.
I shared that. I'm gonna read this.
Yeah, no, Charity is amazing. And full disclosure, she is running an observability company. It's Honeycomb. I use them heavily. I think they're absolutely awesome. I benchmark all other monitoring companies to them, but that's my opinion. And that I've seen it work in production. I've seen it work really well, but they don't do metrics very well, for example. Or they won't work if you have some very exotic apps in very exotic languages, because they don't have libraries for, I don't know, low-level Haskell. They actually do have a Haskell library because I wanted to use it, but let's not go into that. The thing is, unless you've actually run those tools in production, you're not gonna know how they behave. You're not gonna know what their advantages and disadvantages are. Like, I thought Prometheus was awesome.
Interoperate with your other services, SaaS. That's the other big thing is like the SaaS services. They take off a big chunk of work and maintenance off your plate, but then you in the end need to tie them together somehow. So yeah.
Oh yeah, I love when people use different tools. Like, we're gonna put our logs in, I don't know, Papertrail or Elasticsearch. We're gonna put our metrics in Prometheus, and we're gonna look at them in Grafana, and we're gonna put our traces in Yammer, and we're gonna look at them in DeckUI. Good luck debugging the goddamn problem, excuse the language. Okay, so I'm gonna open up the logs. This looks kind of weird. I don't know. Is it running out of memory? Oh, okay, let me open up another window. Oh, of course, this is not in UTC, it's in a local time zone. So let me change that after half an hour of not understanding what is happening here. And so on and so forth.
And that's why Datadog can charge you so much for sending logs their way. It's insane.
Yeah.
If I can generalize, like, Datadog is the best old school provider. They aren't really helpful if you want to do proper observability because you cannot easily find the trace that you're interested in. They do support tagging, but very, very light, and it's not enough. AWS X-Ray has the same problem. They have a lot of very valuable data. It's super hard to find. Yeah. But yeah, Datadog has all three pillars, which is bullshit, but still in the same place. That's it. Honeycomb is the awesome new kid on the block. And I haven't tried Lightstep. I'm hearing good things, but I haven't had the chance of using them in production, so I can't comment.
Cool. You haven't checked that out. Honeycomb.io.
Yeah.
Cool.
That just threw me for a loop. There's a honey badger, which is like a Ruby alerting alert, or like error tracker. And I was thinking, new kid on the block, that thing's old.
So this the original monitoring APM synthetics, New Relic, they actually converted to New Relic 1, and they also changed the pricing plan. Now they are saying it's cheaper. I tried to evaluate, but I think it's still costlier. I was just wondering, if anyone has experience, comparing the cost, which gives you, paying for buck. Like, Datadog, we have New Relic 1 and then Honeycomb. Maybe Honeycomb would be cheaper because it's new.
They're not really in the same area. Like, they all do monitoring, it like saying they all cook food. That's true, but like, one is dessert, one is steak, one is, I don't know, sushi, and the other one is tacos. You can compare them, but it's not that helpful.
Yeah.
I should have added milk in there because people are intolerant to that. That would have been a better metaphor, goddammit.
Yeah, that was a good, I think, overview of the problem of monitoring that we face here with Kubernetes. And last thing, whatever you choose is gonna more or less be hated on in 1 to 2 years from now, and you're gonna wonder why you picked it. So these are. You're going to reevaluate these considerations or these decisions later on, and they are maybe reversible, but there's a huge cost of switching. And you might save some money by switching, but like, is it really going to work out? And and like that two-year horizon, by the time you recoup the money you saved by switching, what is the new kid on the block at that point? So I don't know. Last question that was asked was just a simple one. A lot of experts on the call here, so this is probably not something revolutionary, but I do want to share it since it's a very frequent question I've seen come up. And it's like, NAT instances, NAT gateways on Amazon. This is like Amazon's little ATM machine. They cost a fortune. They convince you to deploy lots of them, and they just print money for Amazon. And most people never have the scale that requires using a NAT gateway for performance. So you want to use, so you see your bill and you're spending $600 a month on all these NAT instances, or $1,000 a month. It's like, Jesus, how do we get rid of it? So the first thing is that, we're just going to reduce the number of them. The problem is that if you want to be operating with high availability, you're going to want at least every availability zone to have a NAT gateway or a NAT instance. But then you think, well, we only really need 2. And then now you're going to complicate this architecture. It's not going to be symmetrical. It's not going to be rubber stamped. And so what we always prescribe at Cloud Posse is build the architecture that makes the most logical sense, and then figure out other ways to reduce costs around that. So as it relates to this, the first optimization is, like, in your dev environments, roll out your NAT instances instead. And if you're using our Cloud Posse Terraform modules, we have a feature flag. You can specify if you want NAT instances or NAT gateways. NAT instances are pennies on the dollar by comparison. You can pick the instance size. Keep in mind that the instance size limits the throughput that you get. And if that's where all your traffic is proxying through that gateway, well, if you're choosing a T1 micro or something, you're going to be limited at whatever that throughput is. The other thing is that in your dev environments, just reduce the number of availability zones. And like one of the arguments was, well, we can just deploy one NAT gateway or one NAT instance in dev, and we don't care about HA. Well, if you don't care about HA, well, then why not just operate in one availability zone to begin with? And then you're going to also save the money on not having the inter-zone transfer costs. So long and short of it is, use NAT instances, reduce the number of availability zones, and first see if that solves your problems. All right, we are out of time for today, right on the dot at 12:30 Pacific here. Thank you so much for the awesome conversation today. Here are some action items for you. If you're new to the call, make sure to sign up to our Slack team. You can go to cloudposse.com/Slack. We have our this recording and all of our past recordings are syndicated to our podcast. So you can go check out our podcast at cloudposse.com/podcast. If you'd like to have some time with me or somebody at Cloud Posse, feel free to go book a session at cloudposse.com/quiz, and look forward to talking with you. Look forward to everyone check out the Office Hours channel. In about an hour or two, you'll see a recording of this call posted there. We'll have the same type of session happening next week at 11:30 Pacific. Take care.
Thanks, Eric.
Thanks, guys.
Thanks.
Bye-bye.
Thank you.
Bye.